This is Mrs. Dawson. Multiply powers. Find 3 to the third power times 3. Express using exponents. We'd like to simplify 3 cubed times 3. So let's write each one of these factors with an exponent. 3 is the same as 3 to the first power. Now that we have a common base of 3, we can add the exponents. 3 plus 1 becomes the new exponent, and 3 plus 1 is 4. 3 cubed times 3 is the same as 3 to the fourth. Let's make sure with a quick check. 3 cubed times 3 is the same thing as 3 times 3 times 3. That comes from the 3 cubed, and then multiplied by 3. Rewriting this with the base of 3, we've got 4 factors of 3, or 3 to the fourth.
Hello, this is Mrs. Workman. Find each product. The first product is m to the third power times m to the eighth power. Notice that both of the factors have the same base. So that means that we can multiply these powers together. To do that, we're going to use the product of powers rule, which says that we're going to multiply these factors by adding their exponents. And so the product is m to the 3 plus 8th power, or m to the 11th power. Let's take a look at the second example. 3r to the second power times negative 5r to the third power. When multiplying, we know that we can multiply constants together and we can multiply factors with the same base. So I'm going to use the commutative property right in here and rewrite this expression as 3 times negative 5 times r squared times r cubed. Here are our constants. A positive 3 times a negative 5 is a negative 15. These two factors have the same base, so we're going to use the product of power rule again. And r squared times r cubed would be r to the 2 plus 3 power. Finally, the product would be negative 15 times r to the 5th power.
This is Mrs. Dawson. Divide powers. Find 5 to the 7th divided by 5 to the 3rd. Express using exponents. 5 to the 7th power divided by 5 to the 3rd power can be rewritten with the common base of 5. However, since we are dividing, we'll subtract the exponents. So 5 to the 7th divided by 5 cubed is the same as 5 to the 7 minus 3. 7 minus 3 is 4. So we have 5 to the 4th power.
This is Mr. Hardesty. In our next problem, we'll find a quotient using powers. Find m to the 10th divided by m squared. Express using exponents. We need to divide, in this problem, looking at variables that are raised to a power. That is, m to the 10th power is being divided by m to the second power. Our rule says if we have the same base, which we do, that's m, all we have to do is subtract the exponents, 10 minus 2. 10 minus 2 is equal to 8. So we can divide and show exponents by simplifying the quotient to m to the 8th.
Example number 6. Simplify using the laws of exponents. For this one, we're going to take 2 to the 5th power times 3 to the 5th power times 5 squared divided by 2 squared times 3 to the 4th power times 5. Basically what you're seeing here is 2 to the 5th power divided by 2 to the 2nd power times 3 to the 5th power divided by 3 to the 4th power, and 5 to the 2nd power divided by 5 to the 1st power. Solve for each one. 2 to the 5th power divided by 2 to the 2nd power is 2 to the 3rd. 3 to the 5th power divided by 3 to the 4th power is 3 to the 1st, or just 3. And then 5 to the 2nd power minus 5 to the 1st power is 5 to the 1st power. So subtracting the exponents. Solve 2 to the 3rd power is equal to 8 times 3 times 5, which gives us an answer of 120.
This is Mr. Hardesty. Let's use a real-world example and the quotient of powers rule. Science. A petri dish contains 10 to the 5th bacteria after 1 hour. After 4 hours, there are 10 to the 10th bacteria in the dish. How many times more bacteria are in the dish at 4 hours than at 1 hour? To find how many times, we're going to divide 10 to the 10th, where we ended up, by 10 to the 5th, where we started from. And to do this, we use the quotient of powers rule, which says if we have like bases, all we have to do is subtract the exponents. That is 10 to the 10 minus 5 power, which is 10 to the 5th. 10 minus 5 is 5, and that is our solution, 10 to the 5th. We can also express that as 100,000 times as much.